Okay, now that we know how to use our calculator, here's where the fun begins. The next study of trig we're going to work on for the next couple of slides is application of trigonometry. What is the purpose of trigonometry? I know the first chapter we focused on definitions, understanding the meaning of the words and what the definitions are, but now we're actually going to apply it. So we're going to combine chapter 2 with chapter 7. That's what all the application is. And yes, I'm going to tell you this right now, it's all pretty much straightforward word problems. That's the whole purpose of math, is to apply to real life situations and use it. So we're going to see in this next couple of chapters, sections we do, the development of how we apply it. Why do we need trig? Well, trig had to come from an extension of we couldn't use geometry anymore. Remember we said trig was the study of triangles. So everything we do in the next couple of sections is all about triangles. And as we started, we said the definition of trig is based off of right triangles. So let's go back and see an application. You remember being in geometry class and seeing a square. Now, what makes a shape a square? What are the properties of a square? Good. You know all four sides are equal measure. And you know all four angles are 90 degrees. So what happens if I tell you I have this square here, and I know for sure the side is 7 centimeters. And the question is to find the length of the diagonal. That's what I want, the length of the diagonal. Well, we know by looking, the diagonal is right here. Now, what happens with a square is when you draw the diagonal in, it breaks the square into two congruent shapes. It breaks it into two triangles, and because they have 90-degree angles, they are right triangles. Correct? So if we look here, I'm just going to blow up one of the right triangles. Correct? And if we know this was the side of the square and it was 7 centimeters, and this is the side of the square, we know it's also 7 centimeters. So from geometry class, if I said find me the length of the diagonal, do you all agree you can use your buddy Pythagorean Theorem? A squared plus b squared equals c squared. Now we're not going to relate that to x, y's, and r's because this is not on the coordinate system. We're not drawing x and y axes in this chapter. Okay? We're not plotting points. So we can just talk about the Pythagorean Theorem as it's the way we used to say it. A squared plus b squared equals c squared. And if a is 7 centimeters and b is 7 centimeters, we could find the length of the diagonal, which happens to be the hypotenuse. Because we know the hypotenuse is always across from the 90-degree angle. So if we do our geometry, 7 squared is 49. 7 squared is 49 equals c squared. We'd add up 49 and 49 and get 98. That equals c squared. We get rid of the square by doing the square root. And then depending on the homework, the way they asked the question, if they said to give the answer in simplest radical form, that would mean to reduce the root. Well, in 98 is the perfect square, 49 times 2. So we know this is going to be 7 square roots of 2 centimeters. If on the homework it said give it to the nearest decimal value, then yes, you would type in square root of 98 in your calculator and get out the decimal value. Also from geometry, if you were quick, you would have remembered, well, one of the things I learned in geometry is this diagonal of the square cuts this 90-degree angle in half. So that means in a square, these little angles right here have to be 45 degrees. So really when I blow this up, this is a 45, 45, 90 right triangle, correct? And from the previous chapter, we learned the sides of a 45, 45, 90 right triangle are in the relationship 1, 1, square root of 2. The only difference here, this is 7 and 7. So think, to make a 1 become a 7, we multiplied by 7. To make a 1 become a 7, we multiplied by 7. So we multiply this side by 7 and this side by 7. We multiply that by 7. That would also give us 7 square roots of 2. That's another way you learn to find that diagonal. But you had to know that when you have a square, the diagonal breaks the triangle into a special right triangle, the isosceles, and you have to know your relationship. Either way, the point is we can use geometry to find the length of that diagonal. We didn't need trig at all. Everybody's good with that? All right. Well, suppose the shape wasn't a square. Suppose it's a rectangle. Suppose this is the rectangle I give you. Well, just like a square, we know some rules. We know in a rectangle, all the angles are 90 degrees. So that's 90, that's 90, that's 90, that's 90. Okay? We also know in a rectangle, the opposite sides are equal. So that base and that are the same length. That and that are the same length. So the left side and right side are the same. The top and the bottom are the same length. We also know when you draw a diagonal in a rectangle, you make, again, two congruent, the same right triangles. So I'm just going to blow this bottom one up. So I blow this bottom right triangle up just so you can see it. That's 7 centimeters. I don't know this side because they're not going to be the same length. I want to find the length of the hypotenuse. I'm going to call that C, which is the diagonal. They give me this angle is 30 degrees. So, now we got some decisions to make. First of all, if this is all we're given, can we do Pythagorean Theorem? No. We cannot do a squared plus b squared equals c squared because we only know one side. So we know from geometry Pythagorean Theorem is not going to work. Unless you remember your rules, that's 30, that's 90, that angle's 60. If you did not know that, then you would be stuck. Okay? If you look at this right triangle, it is one of our specials. It's a 30, 60, 90 right triangle. And we learned in the previous chapter the relationship of the sides. But what happens if you forgot that relationship? Then you'd be stuck and be like, ooh, I don't know how to find the length here. That's where trigonometry comes in. I can find the length of that diagonal by using trigonometry. Okay, I'm going to show you how. Now to do this, you have to listen to me. Because the first thing we're going to do is we're going to redefine the trig definitions, the functions. I'm going to be honest with you all right now. We're not going to work in this next section with all 6 trig functions. When we talk about using trig to solve right triangles, we only deal with the basic functions, sine, cosine, and tangent. And the reason why is on the calculator, we only have those 3 buttons. We have seen now it is really a pain in the butt to use cosecant, secant, and cotangent on the calculator because there is no button for it because then we have to remember to do the reciprocal. So when we start this section, 2-4, 2-5, 7-1, 7-2, 7-3, I'm going to tell you right now, everything is going to be using sine, cosine, and tangent. Just to make life easier because we're going to need our calculators. I think you're okay with that. The second thing is this, we're going to redefine the words. Because these are going to be triangles not drawn on an XY axis, we're not going to talk about the definition of sine being y over r or the definition of cosine being x over r. We're going to talk about the definitions in words. So here we go, people. When we're dealing with right triangles on a flat surface of plane, the definition of sine is now opposite over hypotenuse. The definition of cosine is adjacent over hypotenuse. The definition of tangent is opposite over adjacent. Now you're going to say, so we're changing the meaning? No, we're not changing the meaning. It's just instead of using letters x, y, and r, we're using the words. Let me show you what I mean. From the previous chapter, here's our angle drawn in standing position. This is our x, this is our y, this is our r. So according to this picture, the sine would be y over r. If I take this picture out of this coordinate plane and draw it like this, the definition of sine is opposite over hypotenuse. Well, first of all, if you look at this picture, Who is the hypotenuse? The hypotenuse is always across from the 90-degree angle. That's the hypotenuse. When they use the word opposite, they mean opposite of the acute angle. So if that is the acute angle and I make my finger go across opposite, this would be the opposite side. I didn't change the definition. If the right triangle was drawn in the coordinate plane, sine was y over r. If I erase the coordinate plane, I'm still doing y over r. But now I'm using the words opposite, hypotenuse. So I'm not changing the definition. From the coordinate plane, cosine was x over r. Instead of calling this side x, that's x, this side is next to that acute angle. And that's why we use the word adjacent. Adjacent means next to. Okay? Hypotenuse is always across from the right angle. Here's the right angle. That's hypotenuse. So when I do the cosine and this is not in the coordinate plane, I'm doing adjacent, hypotenuse, x, r. Same definition, just different wording. Tangent. We know in the coordinate plane, tangent was y over x. Well, here we go. Here's the angle theta. Here's our acute angle. Tangent is now opposite, that's the y. Adjacent, that's the x. So all we're doing in this chapter is because we're taking the triangles out of the xy axis. We're not going to use the definitions y over r, x over r, y over x. We're going to use it in words. Opposite, adjacent, hypotenuse. The hypotenuse is the easiest one because the hypotenuse, there's no thinking. The hypotenuse is always across from the 90-degree angle. But when you use the words opposite and adjacent, you're talking about the acute angle. Here's the acute angle. Opposite means across from that angle. Adjacent means right next to that angle. Okay, y'all? So you have to memorize this. O over H, A over H, O over A. A lot of people teach it different ways. I've heard the phrase, oh heck, another hour of algebra. Okay, I went to private Catholic school. I was taught old houses are houses of angels. Most books just call it SOHCAHTOA. If you can write SOHCAHTOA, you know it. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You got to know these definitions in these words now. Okay? So what we're going to do is I'm going to show you if I have this triangle and I only know one side, I can't use Pythagorean Theorem to find the other side. What I could use is trig. So let me erase this and let me blow that up. All right. So here's our problem. I had a rectangle. I broke it up. I was told this was 30 degrees. I was told this side was 7 centimeters. And it said find the length of the diagonal. The side you want to find, you want to label. Now look at me. Most of the times when we label, we use A's, B's, and C's because it's a right triangle. It is understood. Come down here. Big C is always the 90-degree angle. That means little c is the side across. That's why always the hypotenuse is C. So when you draw your right triangles, you label a 90-degree angle letter C. And then across from it, the hypotenuse will be lowercase c. Then the other two angles are A and B. It doesn't matter which one you make which. But here's the rule. If this is angle A, across from it is side A. If this is angle B, across from it is side B. So because we're going to be using Pythagorean Theorem sometimes, we want to use the letters A, B, and C. Just make sure you understand. The angle and the side across have to be the same. Like Dr. Seuss, big A, little a. Big B, little b. Big C, little c. The sides are always lowercase letters. The angles are always capital letters. So here, in this picture, I know this would be C. That's the 90-degree angle. So this diagonal I want to find is little c. All I need to find that missing side is one acute angle and two sides of the right triangle. To use trig, trig is a relationship like we talked about videos ago. an acute angle, one acute angle, and two sides of the right triangle. That does not mean you need to know both sides. You just need to talk about two sides. So what you do to use trig is, first of all, you label your picture. You put your finger on the acute angle. This side is next to the acute angle, so we would call this adjacent. This side cannot be called adjacent, even though it's next at an angle, because it's across from the 90 degrees. So that is the hypotenuse. I don't care about that side. I know nothing about that side. I'm not trying to find that side. Leave that side alone. I was given this side, so I'm going to label it. And this is what I want to find, so I have to label it. So in your picture, I should have an acute angle and two sides labeled with words. Now I look. If I have hypotenuse and adjacent, which trig function am I going to use? I'm going to use cosine. So I'm going to write that rule. Cosine theta equals, and you can abbreviate, A over H. Guys, this is an equation. It has an equals. What do we do with equations? We substitute in what we know, and then we solve it. So now we're going to substitute in cosine. Theta is always your acute angle. That was your definition. Your acute angle was 30. Don't forget the degree symbol. Your adjacent side is 7. Your hypotenuse, you don't know, you labeled it C. Now all we got to do is solve that equation. To solve that equation, we got to get C by itself. Well, that equation is called a proportion. Remember in good old arithmetic, a fraction that equals a fraction is a proportion? So look, if I wrote this on the board, x over 3 equaled 8 over 6. You guys from algebra know how to solve that. You would cross multiply. You would say 6x equals 24, divide by 6, x is 4. That's the same way. This equation is a proportion. This is over 1. I'm going to cross multiply. I want the variable on the left, so I'm going to do this first. C times the cosine of 30 is writing C cosine 30 equals 1 times 7 is 7. Now I want to solve for C, so I got to move cosine 30 over here. It's connected by multiplication, so I'm going to do division. Something divided by itself, the same term divided by itself cancels out. There's C equals. Now when I was in school, again, we didn't have calculators. We had to write, this was the answer. But you know what? That means nothing. What is 7 divided by cosine of 30? You guys are so spoiled. You can now go use your calculators and find out what that number is. So now, this is why we're going to need our calculators to do the arithmetic part. We need the calculator to do 7 divided by cosine of 30. How you read it is how you type it. Let's go to our calculators. All right, here's the 30x. First of all, what mode am I in? Radians. What mode do I need to be in? Degrees, because it's 30 degrees. Let's change the mode. All right, now I'm in degrees. What I read is what I type. I type 7 divided by, I hit the division symbol, I hit COS for cos, and I type 30 and close it. And there comes out my decimal. Everybody's good? I'm going to do it in the Pro. Okay, turn the Pro on. What mode am I in? Radians. Talking about the degrees. It's 30 degrees. Fix your mode. Arrow over. Hit enter so it's highlighted. Get out of that. Second, quit. Now I'm in degrees. I'm going to type 7 divided by, hit the division bar, cosine 30 degrees. If you look, I have the same decimal value. Okay? Now, on your homework, you have to read what they want you to round to. I believe this said round to the nearest tenth. So I'm going back to the board. Cosine is approximately, and if I look at that decimal, if I round to the nearest tenth, it would be 8 and 1/10, and this was in centimeters. Trig is not hard to use, but you have to understand how to work with the picture. You're going to have to touch the triangle. Trig is a relationship between the acute angle. So when we talk about this, we're always doing the acute angle. We're not touching the 90 degrees. And two sides. So you don't want to label all three sides. I don't want to see on the triangle the words written opposite, adjacent, and hypotenuse. If you label all three sides, you'll be totally confused. You label the side you're given, and you label the side you want to find. And that helps you decide which of these definitions you're going to use. Now, I'm going to prove to you I'm right. Because if I go back here and I knew my geometry, this was a 30, 60, 90 right triangle. And from the last chapter, we said in a 30, 60, 90, the side opposite the 30 is always 1. The side opposite the 60 is square root of 3. And the side opposite the 90 was 2. Correct? We wanted to find this side. Side C, right? The diagonal. So, what we have here is 7. Okay? This is square root of 3, and we want to make it a 2. Well, in geometry, you would have had to know how to make that number become a 2, and then we would do the same thing with this number. We'd make it a 2. Well, believe it or not, that's so much more work. Trig is so much more easier. All right, we're going to try one more example going slow using trig. So let me get my notes out. It is example 2. Would everybody get example 2 out in the notes? All right. I'm going to need the whole board for this. Okay. All right. Example 2. The picture is already drawn for you, which is great. If the picture's not drawn, you draw it. These are everything we do in this section is about right triangles. So the right triangle is always labeled with big C. They have B here and angle A here. We always know if this is big C, this is side C. That's big A, this is side A. That's big B, that's side B. In 2, it says solve the right triangle given. And this is what they give you. Angle A is 62 and 5/10 degrees. And little a is 12.7 meters. And that's all they give you. When it says solve the triangle, first of all, it means find all the missing parts. Well, a triangle is comprised of 3 angles and 3 sides. So there's 6 parts. They're only giving you 2. So the first thing, what I do in my notes is I write down. When I say solve a triangle, they want to know little a, little b, little c. They want to know the measure of angle A, the measure of angle B, and the measure of angle C. So in your homework, there'll be, if it says solve, there's going to be 6 spaces. They want 6 answers. First of all, let's list what we got. We know angle A, big A, is 62.5 degrees, or 62 and 5/10 of a degree. We know side A is 12.7 meters. By looking at the picture, we also know angle C is 90 degrees. So we know 3 out of the 6 parts, and that's what's going to happen. We're going to know 3 out of 6. Now, first thing you need to do is put the information given into the picture. When you put a side, you put it on the outside here. And when you put an angle, you put it on the inside. So if you look, we have 3 different things to find. We got to find side B, side C, angle B. There is no right or wrong here. If you can use geometry, I would use geometry. If you have to use trig, then you have to use trig. So the first thing, it looks like here it's going to be easy to work with the angles. Because if we know 2 angles, to find the third one, we don't need trig. We need geometry. From geometry, we know in a triangle, 3 angles add up to 180. Correct? That's a straight rule. We also know in geometry, if this is a right angle, these 2 angles, angle A and B, are always complementary. So angle A and angle B always have to be complementary if you have a right triangle. And from the first lecture, what does complementary mean? It means they add up to 90. So this would be a quick thing. that would be the first thing I would do is find the missing angle, because if I have two, the third one's not hard. Angle A and angle B have to add to 90 degrees. So I would do 90 degrees minus 62 and 5/10 degrees. All right, I'm going to put my decimal point, put a 0. I can't do 5 minus 0, so I borrow from 90. I make it 89. That becomes a 10. 10 minus 5 is 5. 9 minus 2 is 7. 8 minus 6 is 2. And there's your missing angle, 27 and 5/10 degrees. So don't be afraid. If you wanted to add up all these angles to 180, so if you wanted to add up 90 and 62 and 5/10 and subtract it from 180, you'd get the same thing. So do the easiest part first, which is if you have two pieces, find the third piece. Now, it's the sides that are going to be the problem. Because normally to find a missing side of a right triangle, we're supposed to do Pythagorean Theorem. But do I have enough to do a squared plus b squared equals c squared? No, I only know a. So Pythagorean Theorem's out. So you're going to need to use trigonometry. So the hardest part is getting started. Now look, I just found this angle. I didn't put it in the picture, and I'm not. The only thing I want in the picture is the given information, because that's how I'm going to start with trig. Trig is a relationship between an acute angle and two sides of the right triangle. First thing, put your finger on your acute angle. There it is. This side that we know is across from that acute angle. So what word are we going to use? We're going to call this side the opposite, because it physically is across opposite of the angle. Now, we don't want to label both the other sides with words. We only want to pick one side. So you decide first. Do you want to find side B or C? I like to go in order. Let's find side B. So what word would I give to B? If that's opposite, then this is either adjacent or hypotenuse. Well, we know it can't be the hypotenuse, because the hypotenuse is always across from the 90 degrees. That would be side C. Side B must be the adjacent side, because it is next to the acute angle. So now, if I look at my words, I have opposite and adjacent. And if I look at my new definitions, SOHCAHTOA, opposite and adjacent would be tangent. So I'm going to write the tangent of theta equals opposite over adjacent. That's our rule, our definition. Now I'm going to do is fill this in. The tangent. Theta is always our acute angle. Our acute angle was 62.5 degrees. Our opposite side is the 12 and 7/10. Our adjacent side is what we don't know. We're going to leave it as B. If it helps you like it helped me, I always put this over 1 so I could see the proportion. I'm going to cross multiply. I want my variable on the left, so here's the B. So I'm going to write B times tangent of 62 and 5/10 degrees equals 1 times 12 and 7/10 is 12 and 7/10. To get B by itself, I have to move this expression tangent over here by doing division. I got to take the word and the angle. They go together. Something divided by itself cancels out. There's the B. When I was in school, we left the answer as 12 and 7/10 divided by tangent of 62.5 degrees. Don't forget your degree symbol. Now here's the difference. You guys have calculators, you have technology. That's unacceptable anymore, because let's find out what it is. Let's go type it in our calculator. All right. Our calculator has to be in what mode? Degrees. All right. So I'm on 30. Clear it out. Let's check it. Yep, I'm in degree mode. I typed what I wrote. 12 and 7/10 divided by tangent 62.5. It's in degrees, so I don't got to put the degree symbol. And hit equals. You do the same thing in the pro. They're going to tell you on the homework, I'm going to come back to the board now. They're going to tell you in the homework to round. I believe this one said round to the nearest tenth. So we'd write B is approximately 6 6/10, and you must label the units. This was in meters, so this was in meters. So now I'm going to come here and put it. So now I know by looking here I have 5 out of 6 pieces. Everybody's good? Not hard. The hardest part about using trig is understanding the only information should be in the picture is the information that was given. They gave me this angle, they gave me this side. Now, these both sides were missing. I chose which side to find first. I wanted to find side B first. So that's why I labeled that side and I knew that side. Okay, now we still have to find side C. Now you have options. Okay, the better option to me is I like using trig. I'm going to use it again. To find side C, I'm going to erase this word. I'm done with B. I'm not putting the 6 6/10 in this picture. I still know here's my acute angle. Here's my opposite side. If I want to find side C, it is not adjacent. It's across from 90 degrees. It's the hypotenuse. So to find side C, I will use the trig function with opposite and hypotenuse. So if I come up here and I write SOHCAHTOA, I need an O and an H. OH, that's sine. So I'm going to erase this. And I'm going to write the sine of theta is opposite over hypotenuse. Those are my words. I'm going to fill this in. The sine, what's my acute angle? Equals, what's my opposite side? I don't know my hypotenuse. That's why it's labeled C. To solve these definitions, these equations, they're proportions. You cross multiply. We like our variable on the left, so it's C times this. So I write C sine 62.5 degrees. 1 times 12 7/10 is 12 7/10. To get C by itself, we're going to divide by that trig function. Cancel out, exact same amount. C equals, in my day you left the answer as 12 7/10 divided by the sine of 62 5/10 degrees. Now I know what some of you are thinking. Some of you are thinking, well, Miss Black, why don't right here we just make the decimal? Remember, that decimal is going to be this long. Do you want to keep typing that decimal over and over again? No. That's why we're not touching the calculator to the very end. Secondly, it's much easier for it to go through your work and see your steps if you leave the trig word in till the very end. So don't use your calculator till you get who you're trying to solve for isolated. Now I agree. Let's go type this in our calculator. Okay, I'll do the pro this time just to show you they work the same way. So what mode do we have to be in? We have to be in degree mode. We are. It says up here we're going to take 12 7/10 and divide it by the sine. So we're going to hit now the sine button of 62 5/10 degrees. Because we're in degree mode, we don't need to put the degree symbol. And there's our answer. There's our exact answer. It's going to say to round it to the nearest tenth. They're pretty standard. And that would be 14 3/10. And make sure you label it meters. And we just finished solving that triangle. Now, I said you had options. You did not have to do trig to find side C. If you knew side A was exactly this decimal and you found side B, you could have found side C by doing Pythagorean Theorem, but here's what I'm going to warn you about. When we found side B to be 6 6/10 meter, was that exact or did we round it? We rounded it. If I go back to your calculators, here was side B exactly. And that is the exact value of side B. So here's what happens. If you use this, the rounded answer, in Pythagorean Theorem and did a squared plus b squared to get this, then this would be off. So here's my warning to you. You never use a rounded answer to get the next answer. If you wanted to do Pythagorean Theorem to find side C, I'm fine with that. You could write a squared plus b squared equals c squared. You know that's exact because that was given. Side A is 12 7/10. That's exact. But for side B, you cannot use this rounded answer. Let me go get my calculator. You would have to use for side B the whole decimal that the calculator spit out. All of that. So that's my first thing. You never use a rounded answer to get the next answer. Now, don't cry. You could type that all in your calculator in one fell swoop. I'll show you. Okay, it doesn't matter which calculator I'm using. I would put open parentheses, 12.7, close it, and you all have a square button right there, x squared. There's the square. Plus, parentheses, type that lovely long decimal in exactly. And that's where your errors are going to be, people, is typing them in. Close it. Go get the square button. See it? Hit equals. Do not round that. That has to be written completely out, that whole decimal. Okay, I'm going to put that on the board. So you get 204 decimal point and all this equals c squared. So we worked all that on the calculator. It's great. How to get rid of a square? You do the opposite. You square root. Again, do not cut that. You square root the whole thing. So I'm going to go to my calculator, and your square root button, believe it or not, is with your square button. Here's my square button on the 30. The square root's up here in blue. So I have to hit second square root. So I would have to type in second square root. So I'm going to clear this out. I do second. I would do stat. Hit the square button. There's the square root. The square root should put a parentheses, and then you type your decimal in. Is that the 14 3/10? Okay. Just so you can see on the pro, here's the pro. The pro has a square button, and above it in blue is the square root. So to get the square root button, you have to do second square root. So the moral of the story is I do not care. If you can use geometry rules, that's great, but don't ever use a rounded answer to get the next answer. You have to use the whole decimal value to get to the next answer. But sometimes geometry is not going to work, and we're going to have to use trig. Now, we're going to do one more example in the next video on how you work this if you're not given the acute angles. So I'll see you in the next video.